This lecture on graphs of trigonometric functions is done on behalf of the Independent Learning Center of SKU. My name is Gerald Wanjala. To begin with, let's consider a unit circle. That means a circle of radius 1 with center at the origin. This circle is indicated down here. So the circle indicated down here is what we call a unit circle. It's a circle of radius 1 which has a center at the origin. Since this circle is a circle of radius 1, we say that if one moves from the point 1, 0 along the circle and comes back to that same point, the distance covered is 2 pi because the radius of the circle is 1. If one moves from the point 1, 0 up the point 0, 1, the distance covered is pi over 2. If one moves from the point 1, 0 up the point minus 1, 0, the distance covered is pi. And if you go from the point 1, 0 up the point 0 minus 1, the distance covered is 3 pi over 2. We know that since the terminal point of t gives us sine t and cos t, that is the x coordinate of the terminal point of t will give you the cosine of t, and the y coordinate of the terminal point of t will give you the sine of t. Then we say that as t moves from 0 to pi by 2, the sine of t moves from 0 to 1, and the cosine of t moves from 1 to 0. As 1 moves from pi by 2 to pi along the unit circle, we see that sine t moves from 1 to 0, and the cosine t moves from 0 to minus 1. We also see that as 1 moves from pi to 3 pi over 2 along the unit circle, the sine of t moves from 0 to minus 1, and the cosine moves from minus 1 to 0. And lastly, as you move from 3 pi over 2 to 2 pi, the sine t will move from minus 1 to 0, and then cosine t will move from 0 to 1. So from the unit circle here, we see that the sine of t plus 2 pi the same as the sine of t. For example, if t is pi by 2, then we know the sine of t is equal to 1. So if you move from 0, 1, go around the circle, and then come back to that same point, still the terminal point remains the point 0, 1. And therefore, the sine of t still will be 1. So the sine of t plus 2 pi will be equal to the sine of t. Similarly, the cosine of t plus 2 pi will be equal to the cosine of t. So this means that the functions sine and cosine are periodic with the period 2 pi. In general, we have that the sine of t plus 2k pi is equal to the sine of t, and the cosine of t plus 2k pi is equal to the cosine of t for any integer k. Using the unit circle, we see that the graph of y is equal to sine x if x is measured in radians is as given down here. We see that the sine of 0 is 0, the sine of pi by 2 is 1, the sine of pi is 0, and so on. And similarly, if y is equal to cos x, where x is measured in radians, then the graph of y is equal to cos x is given down here also. If y is given by y is equal to a sine k x minus b, or y is given by y is equal to a cos k into x minus b, then the amplitude of y is the absolute value of a, and the period of this function y is 2 pi over k. The number b is called the phase shift. Now let me explain to you how we sketch graphs of such functions. Down here, we have given a sketch of the graph of the function y is equal to 3 sine 2 into x minus pi by 4. Here we see that the amplitude is 3. The period is going to be 2 pi over 2, so the period will be pi, because in this case k is equal to 2, and then the phase shift will be pi over 4. So the graph of this function y is equal to 3 sine 2 into x minus pi over 4 is given here in red. It has amplitude 3, it has period pi, and has phase shift pi over 4. So let me explain to you how we get the graph of this function y is equal to 3 sine 2 into x minus pi by 4. We notice that this is the graph of a sine function. So we begin with the graph of y is equal to sine x, which is given here in black. Now, the 2 tells us that we are going to shrink this graph horizontally by a factor of 1 over 2. For example, this point pi will become pi over 2. The point minus pi here becomes minus pi over 2. So we shrink the black graph horizontally by a factor of 1 over 2. Then we get the blue graph. The blue graph is the graph of y is equal to sine 2x. Now, the first shift, pi over 4, tells me that I shift the graph of y is equal to sine 2x to the right through pi over 4 units. And when you do that, you get the green graph. You shift the blue graph to the right through a distance of pi over 4 units, then you get the green graph. But then we have to multiply it by 3. That means you stretch it vertically by a factor of 3. So finally, you stretch the green graph vertically by a factor of 3. So for example, the point minus 1 here goes to the point minus 3. So when you do that, then you eventually get the red graph, which is the required graph. That's the graph of y is equal to 3 sine 2 into x minus pi over 4. An easier way of sketching such a graph is to identify the interval on which you can sketch one complete period. So such an interval is given by b to b plus 2 pi over k. So for example, let's consider the function y is equal to 3 sine 2 into x minus pi by 4. In this case, the interval on which we are going to sketch one complete period is the interval of pi by 4 up to pi by 4 plus 2 pi over 2, and that will give you the interval pi by 4 up to 5 pi by 4. So this is the interval on which we will sketch one complete period of the graph of y is equal to 3 sine 2 into x minus pi by 4. So since this is a sine function, we start by sketching the graph of y is equal to sine x. We sketch that graph for one complete period, and that is from 0 up to 2 pi. Such a graph is indicated here in black. Now, we know the interval on which to sketch our required graph is the interval pi by 4 up to 5 pi by 4. So we just sketch a graph similar to the black one because it's a sine graph, but then beginning from pi by 4 and ending at 5 pi by 4 and having amplitude 3. So that graph is sketched here in green. Then once you have done that, once you have sketched the graph on the required interval b up to b plus 2 pi over k, in this case, which is pi over 4 up to 5 pi over 4, then you repeat it on the right hand side and the left hand side, and that gives you the required graph. So here we have sketched the graph in green, and then we continue with the same graph on the right and then the same graph on the left, and that gives you the complete graph of y is equal to 3 sine 2 into x minus pi by 4. Sketching graphs of the tangent function is similar to sketching graphs of the sine and cosine function. Let's call here that tan t is given by tan t is equal to sine t over cos t, and since cos t is equal to 0 when t is equal to either pi over 2 or minus pi over 2, we see that the lines t is equal to pi over 2 and t is equal to minus pi over 2 are vertical asymptotes of tan t. Since tan t is positive in quadrant 1 and negative in quadrant 2, we see that tan t goes to infinity as t goes to pi minus 2 from the left, and that t goes to minus infinity as t goes to minus pi by 2 from the right. So using that information, we can sketch the graph of y is equal to tan t, which is given here below. We see from this portion of the graph that as t goes to pi over 2 from the left, then tan t goes to plus infinity, and that as t goes to minus pi over 2 from the right, then tan t goes to minus infinity. So we sketch this graph here in the interval minus pi by 2 to pi by 2, and after that just keep repeating the same graph both on the right and on the left, since the graph since the function is periodic with period pi. And that gives us this graph here. So we see that tan x plus pi is the same as tan x. And in general, we have that tan x plus k pi is tan x. In other words, the function tan x has period pi. The appropriate interval on which to sketch the graph of y is equal to a tan k into x minus b for one complete period is the interval minus pi over 2k plus b to pi over 2k plus b. So below here we sketch the graph of y is equal to 3 tan 2 into x minus pi by 4. So we know the interval is going to be from 0 up to pi over 2. How do we get this? We write minus pi over 2k plus b and then pi over 2k plus b. In this case, b is pi over 4 and the k is 2. So that gives us the interval 0 up to pi over 2. So we sketch the graph on the interval 0 up to pi by 2, which is indicated here in green. Then we repeat the same graph both on the right and on the left. And then we get this graph here. In order to define inverse trigonometric functions, let's consider the graphs of y is equal to sine x and y is equal to cos x given here below. If we look at these graphs, we see that any horizontal line which crosses these graphs will cross them at infinitely many points, and therefore the functions y is equal to sine x and y is equal to cos x are not one-to-one functions, and therefore we cannot talk of the inverse functions of sine and cosine. For us to be able to talk of the inverse sine function and the inverse cosine function, we need these functions to be one-to-one. And in order to obtain that, we have to restrict the interval on which these functions are defined. So for the sine function, we restrict the domain to be from minus pi by 2 to pi by 2. And the cosine function, we restrict the domain to be from 0 up to pi. So if we do that, then we get this portion of the graph here indicated in red with full line. From here to here for the sine function, and for the cosine function we get this portion of the graph from here up to there. So we see that any horizontal line which crosses these portions here will cross them at only one point, and therefore if you restrict the domain of the sine function from minus pi by 2 to pi by 2, then the function becomes one-to-one, and so you can have the inverse sine function. The same applies to the cosine function. So this gives us the following. One, that the sine inverse of y, we can define the sine inverse of y to be x if and only if sine x is equal to y, and y belongs to the interval minus 1 to 1. X belongs to the interval minus pi by 2 to pi by 2. Similarly, we can define cos inverse y to be x if and only if cos x is equal to y. Y belongs to the interval minus 1 to 1, and x belongs to the interval 0 to pi. For example, we have that the cos inverse of cos 3 pi by 2 will be cos inverse of 0 because the cos of 3 pi by 2 is 0. And that should give you an angle in the interval 0 to pi whose cosine is 0, and that angle is pi by 2. For the tangent function, let's assume that y is equal to tan x. Then if you look at the tangent function here, any horizontal line which crosses this graph will cross it at more than one point, and so the function is not one-to-one. So in order for us again to be able to talk of the inverse function of tan, we need to restrict the domain on which this function defined so that the resulting function is one-to-one. So the domain, the appropriate domain is the domain minus pi by 2 to pi by 2. So we see if we do that, then any horizontal line that crosses the graph will cross it at only one point. So in that case, we define tan inverse y to be equal to x if and only if tan x is equal to y. Y is a real number, and x belongs to the open interval minus pi by 2 to pi by 2. So we see that tan inverse minus 1 is the angle minus pi over 4. How do we get this? We look for an angle in the interval minus pi over 2 to pi over 2 whose tan is minus 1, and that angle is minus pi over 4, and therefore tan inverse minus 1 is minus pi over 4.